Now let us look at the second chapter, practice problems. For 13, a set of data is summarized by the stem leaf plot below. Answer the following questions. How many times the value 56 appear in the data set? So 56, right? You just check the stem here, if 5 here, and the leaf, which is 6. So we have 1, 2, right? 56 here and 56 here. So we be 2, right? How many values of the data set are greater than or equal to 40, but less than 50? So from which is from 40 to 49, right? So you can check this row here. 1, which is 40, 40, 40, right? So you just count how many leaf here, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So it's 14, right? 3, 6, 9, 12, 14. Complete the frequency table below to represent the data given in the stem and leaf plot. So for this table, right, before you can complete, you need to write down what the classes, right? So for 20 to 29 here, so we expect here we get 30 to 39, right? 39, right? And 40 to 49. My writing is kind of beautiful. Okay. But the good news is you have a solution too, right? But here I just put it here. 40 to 10 to 19, right? It should be number 1. Okay. Okay. So I'm bad at it. Okay. But anyway, you know it, right? You know it already. So 91, 9. Okay. That's good. So let's see how many from 20 to 29. You just count, right? How many live here? 1, 2, 3, 4, 5. So you just count by 3. 3, 6, 9, 12, 15, 18, right? So 18 here. 1, 8. 30 to 39. 3, 6, 9, 12, 15, 18, 20. 40 to 49. 3, 6, 9, 12, 14. And 50 to 59. 3, 6, 9, 12, 14. Okay, let's check. 8, 9, 18. 20, 14, 14. Okay, good. We made it. Let's look at number 14. The bar graph below shows the number of boys and girls in different classes at a certain school used to answer the following questions. Which class had more boys? How many girls are in Mr. Brown class than Mr. Johnson class? What percent? Okay, so let's go one by one. Which class has more boys? Brown or Johnson? Brown, yeah, Brown, right? They have 16 boys. Johnson only have 14, right? How many more girls are in Mr. John Brown class than Mrs. Johnson's? So Mr. Brown, you have 16, right? Girl Johnson, you only have 11, right? What percent of students in Mr. Brown class are girls? So for Mr. Brown, you see that boy and girl are the same, right? So which is 50% of girls, 50% of boys. What percent of all students are in Miss Brown class? So for Miss Brown, she got 32 students, 16 and 16. And the total student for this data, right? We have like for Mr. Johnson, we have the 14 plus 11, which is 25. So total student here would be 32 plus 25, which is 57. So the percent of student from Mr. Brown class would be 36 divided by 57. And this will give you the percent, right? So let's look at the answer here. We had class had more students, Mr. Brown, right? How many more girls are in Mr. Brown class than Miss Johnson class? You can see 16 subtract to 11, right? What percent student Miss Brown class are girls? Have 50%. And again, the percent student come from Miss Brown class is 32 by 57, right? Number 15. Mark is keeping track the total number of movies he has watched over time. Oh, so we talk about total, right? The line graph below show the data. Use it to answer the following questions. So here we have a graph with the total movie watched over time and week, right? So in the first week, a total you have Mark watched 2. After which second he watched, the total is 6. The third week he a bit more busy, right? He just watched 1 movie, so make a total 7. And 8. The fourth week is 8, and then 9. Okay, so this week it kind of a big increasing, right? Maybe before break. So well, how many movies did Mark watch in total? So you can see here the accumulative here tell us 9, right? 9. Mark watched 2 movies during the first week, right? And 4 movies during the second week. How many movies did Mark watch during the third week? So the third week, which is this from 2 to 3, right? Which is increased from 6 to 7. So we get 1 movie here. Which week this Mark watched the movie, right? So you can see the the slope here, right? It increased quite steep here, right? So this is the week he watched most movie, right? Which he would say in the which one does with 2, right? Which is second week. So let's look at the answer together, right? 9 total, 1 movie, and during week 2, right? That's clear, right? So 16, as part of an effort to reduce patient costs, a hospital analyzed the number of visits by a nurse for 13 patients over a 10-day period. The average number of nurse visits per day for the patient is given below. So what happened in here, basically like each patient, right, when they stay in hospital, they get nurse visit, right? So say if I stay in hospital for 10 days, and each day I get a certain number of visits, right? Maybe the first day, I just go to the emergency room and I got so many visits, right? And the second day, and the third day, and the fourth day, and I say before discharge, which is the 10 days, right? And I get less visit, maybe more visit, right? But say during my day number 7, 8, I get less visit because the situation getting better, right? Better. So this they calculate the average, right? And maybe for some people with say more kind of in a highly needed help from the nurse, right? And maybe the average maybe come up to like 13 visits, right, per day, right, during the period they stay. So this is what the nature of the data. If we want 4 classes, what class width should we use? So reminder here, class width just the max subtract the mean divided by number of classes. So here, like, you can use that number, or you can choose anything bigger than, right, greater than equal than that number. But for sure, we don't want it too big, right? Because if that's the case, and then uh, mm, all of the data may fall in just one class, right? So for the class width here is the max subtract the mean divided by number of class. So for this data, the max is 13, the mean is 3.6. So what you need to do with that, just 13 subtract 3.6 and divide by 4, right? You just choose a number bigger than that, right? But for sure not too big, right? So okay, you get like 2.35 and you round up a little bit, right? With 2.4. Starting with minimum value in the data set as a global class limit, complete the frequency table below. So here, like, you can do the lower class, right? With the class with 2.4, like here. So you just add up here 2.4, which makes 6, 2.4 makes 8.4, and 2.4, right? It makes 9. And from that, you can get also upper class limits, which you go down 1 unit, right? Here, 1 decimal from the upper, lower bound, the next from the next row, right? So here will be 3.6 plus 2.4, right? So here we use 2.4 here. So you add up 6, 8.4, 10.8, right? 10.8. Yeah, I'm sorry, it should be 10.8, not 9. And then upper class limit just go down a little bit, right? 6 to 5.9, 8.4 to 8.3, and 10.8 to 10.7. And the last guy here, which you just use this guy, 10.7, you plus 2.4, and it gives you 13.1. And from that, you can tally the value. Just check how many between 3.6 to 5.9. And the good news here is things get order already for you, right? So how many value from 3.6 to 5.9? You have 1, 2, 3, 4, 5, 6, 7, 8, 9, right? 6 to 8.3, you get this. 8.4 to 10.7 and 8.10 to 11.3. So this is give you the table, right? 17, a personal trainer analyzes the progress of her clients. So she calculates the body mass index for each. The BMI for all of her current clients are summarized in the histogram below using the lower class limit to label the x-axis. Okay. What is the class width? So because the good news here is all the lower class limit, right? You label here. So just the difference between 2 consecutive low class limit. So you just use 20.7 subtract 18.1. And if we give it 2.6, right? 2.6. What is the frequency of the class at least 23.3 BMI and less than 25.9? So I think there's some redundant here. What is frequency of the class with at least 23.3 and less than 25.9? So which is this class, right? From 23.3 to 25.9. So the frequency here is the top number here. which is 5. How many clients does she train total? So just add up, right? 1, 3, 5, 2, 1. So 9 here, 11, 12. Right? She would like to offer a $50 discount for next month training to her clients that have currently been at least 25.9 in order to encourage them to keep working with her. If she would offer this, how much total money would she give to the discount next month, right? So from 25.9 and above, you got 3 clients, right? So if she offer $50 for each of them, so which means in total she need to offer 150, right? 50 times 3. So let's check the solution. Here, right? 5, 12, and 150. Let's move on to the section 2.3, measure of the location of the data. So in 18, we have a table of test scores for 35 such students. The score was ordered in the ascending order already, so which is the good news. There are 5 questions. The first one, find the 30 percentile value. So if you remember the formula at the end of chapter 2 in the percentile, right? We have formula to find this value. It's basically just the H value from the left in the ascending order. And where H is calculated by the scaling of K times N here observations and divide by 100. So let me just quickly show you where it is, right? So this is given pk, what is the value x tied to k? So value x tied to pk is the h value from the left, calculated by this fashion. So given that, you can obtain this value easily, right? By doing this calculation. So it will be the h value from the left is equal to k, which is 30, times n, which is, we have 35, and divide by 100. So if you perform a calculation from your TI, you should get 10.5 here, cell, which is 11. So just count here, 1, 2, 3, 4, 5, 6, okay, 10 here, right? 11, which is this value. So which is 67. So let's check the solution here. Oh, in the solution here, they use a different way, a modified version. So you can use either way, right? This way also sometimes people use by using the k divided by n, which is 0.3 here, k divided by 100, I'm sorry, which is 0.3 here, and time to n minus n plus 1 here, so which is 35 plus 1, which is have 10.8, and then they go down, which is a 10 and 11, which is now round up, which is a 66 and 67 here, and they do average, and they get this value as well. So you can use either way. This way to me it's a bit easier to follow. But if you go with this strategy, you also get a full grade. So there are different way, people calculate this, and the difference will get resolved, when we have a larger data set. Say, if you have like 1,000 or 2,000 data points, and at a time, use either the method, it also often just give you the same value. The discrepancy will get result itself. For smaller data sets, sometimes you see a discrepancy when you use different strategy to calculate these values. So you see that sometimes you use one calculator, maybe a TI and another type brand. You may see this value different. Okay, if they have the function to find this percentile, I say you use a different software or Python, and it's sometimes just produce different numbers. It just really depends on how it's the algorithm was written, like which formula they use. And then what is a Q3? The file number is some number summary, the IQR, and we also need to look at the outliers, right? So to answer these questions, the Q3 is a 75 percentile. You can follow the same strategy like we did just in A, right? Using 75 times 35 divided by 100 and save it. But because in any case you need to find a file number summary, so I believe probably it's a good idea to just plug in your calculator, right? So this way you can get the accurate value. You can do it manually for sure, but I would not recommend, especially in the test room, you have a time constraint, right? So you plug on all the value in the tier calculator in the list L1, and you check out the file number summaries, which is the min, which is 18 in this case, the max 99, the Q1, Q2, Q3, and then you get the file number summary. You also get Q3 for this answer. And the interquartile range, it basically just a Q3 subtract a Q1, right? Q3 subtract Q1. So let us just refer to solution. So you can say sometime for other question as well. So here, like the second bullet, here they use a strategy, but I think it may be the best option for you. In the test room, you see such a questions by plugging this in a L1 list and do one variable start. So you can get the mean is 18, the max is 99, Q1, Q2, Q3, and just use that to answer B, right? And again, in the quarter range, just Q3 subtract Q1 here, and you get 13. And in E, we ask about outliers, right? So the definition of outlier is any value less than the Q1 subtract 1.5 IQR. So in this case, the 1.5 IQR is 19.5. So any value below 46.5 or bigger than Q3 plus 1.5 IQR. So you can see that what we need to do, you need to check all the value less than 46.5. So this case, you have like 18, 42, 44. And any value bigger than 98.5, and you get one value here, right? So here you get all the outliers. In this case, you have 4 outliers. Number 19, answer the following questions given box plots A and B below. So you have 2 box plots. Which graph A and B has higher median? So you can see the median, which is the middle line here, right, in the box. So the B, we have the higher median, right, B. B, we have higher variance, higher median, right? Which graph A or B has larger IQR? So the IQR is calculated by Q3 subtract Q1, which is basically it's just the length of the box, right? Length of the box. So you can see the box A has a higher, bigger length, right? So this much, right? The box A is, but box B, this much, right? So basically here A. Does graph A have any outliers? What about graph B? So you can see for both graph, the outliers often, represented by asterisk, right? For in a box plots, um, but say you can also look at um, so in C, the graph A have any outliers? What about graph B? So here, in order to check the outliers, we can do the calculation, right? From here, you can see what the Q1 for plot A, what the Q3 for plot A, and we just calculate the value if we have any value bigger than Q3 plus 1.5 IQR less than Q1 subtract 1.5 IQR. And for same for B, right? Same for B. So which means in this case, if you do this kind of calculation, right? So let's see. I think here we have a calculation ready for us, so we don't need to redo it. Okay. Then look at the solution. So for plot A, right? In the cutoff for the lower value will be 1 because 10 is the first quartile. Subtract 1.5 IQR, which is 6 in this case, and you got 1, and the cutoff for plot upper cutoff will be 25. So here you have like outliers, which is all the values below 1 for plot A, all the value above 25, right? So for plot A, we don't have anything, right? No outlier here because all the values are bigger than 1 and less than 25. The same for plot B, right? You can also see the cutoff range, which is Q1 subtract 1.5 times IQR for plot B, which is 5. And so anything less than 3.5 or bigger than Q3 plus 1.5 IQR, which is bigger than 23.5. So in this case, you have one value, at least, the mean, right? At least the mean is an outlier. You may have more, but at least the mean, right? The minimum value is an outlier. In section 2 and 5, let's see, find the mean of frequency table. So we have a formula for that, right? For the frequency table for the mean. And basically what happened is that we just use the midpoint times the frequency, midpoint times frequency for each class, right? And add them up and divide by the total frequency. So the midpoint of this class will be 3.6 divided by 2, which is 4.5. This guy will be 8.5, right? 8.5. This guy will be 12.5, right? 12.5. And this guy will be 16.5. So from that, just use like 4.5 times 7 plus 8.5 times 4 plus 12.5 times 8 and plus 16.5 times 1 and divide by the total, which is 7481. So which is 24. So it will give you the mean. So let's see what's the calculation here. 20? Oh, 20, right? 11 or 20, not 24. I'm sorry, 20. The total is 20. So I give you the mean here, right? So in this case, then the next question is that would the mean or the median be better measure center for the data? So this data set is really unclear if we have an outlier or not, right? It seems to me there's no outlier, outlier here. And because if we have outlier, which we should have something far away, right, from either side. But here it seems like no outlier here. So given that, it seems to me it doesn't matter, right? Mean a median can work well. So let's see what the answer here. Uh, mean no outliers. I don't think the mean. You have to choose a mean because often a lot of time the median also can serve very well in either case with outlier or with no outlier. Okay. Um, but here like the answer is choosing the mean because no outliers. I mean it makes sense to choose a mean, but Even people use the median, I don't think it will hurt at all, right? Because the median is very strong. I would believe it's, if I have to choose one, I would choose the median because it's very resistant, it's a very strong measurement. And for the central tendency of the data. Find the mean, median, and mode of the following data sets. Also determine whether the mean or median is a better measure of the center. So let's see. Mean, median, mode, right? So the mean is just average, right? The median is the Q2, and the mode is the one who is appear the most, right? So for this data set, so I would recommend for this kind of data set, just plug in a L1 list in your TI calculator, and then you can get your mean and your median, right? So this way will be faster. You can also reorganize by order that and calculate the mean and median. Either way, but given the time constraint in your test, right? I think it's a good idea to follow the strategy. So let's do the TI calculator. And we will do one case, okay? In other case will be similar. $28, $30. Start here, edit, 28, 30, 26, 26, 51, 26, 51. 26, 30, 26, 30, 29. Let's check, okay? 26, 30, 29. So now you do start again, and you go to one variable start and choose L1. So the mean is 30.75, and the median, you see, you can also get the minimum value, is 26. The median is 28.95, and the max is 51, and the Q3 30. So from here, you can see that we have the mean with the median from the output, right? Which is the Q2 here. The mode for this case, which data point appear most, which is 26, right? Which is the mode here. So again, also determine whether the mean or the median is better measure of the center. So we can follow the previous strategy, right? By using like 1.5 IQR plus Q3 for the upper cutoff and Q1 subtract 1.5 IQR. And from that, you can see that I believe the 51 should be the outlier. And even you don't do the calculation, right? But you see the bulk of the data, it's just from 26 to 30, but eventually, just this guy jump in. So pretty much it destroy everything, right? So which means like the median will be a good choice, right? A good choice. You can do the same thing here, right? Same thing here. But this bulk data, I don't see anything strange, right? No, nothing strange to me here. But you can also plug in a list and check it, right? And nothing strange. And again, and people say they can use mean. They say because it just take into account everything, right? But I don't think it's hard if you use median either, and because median is very because a non-parametric style. Okay, it doesn't affect much by the presence of outlier, and even with no outlier, it's still a good candidate to show a central tendency. But again, for this type of question, if you put mean and median, I think it's a problem. You should get your full credit here. But for this question, right, because the outlier there, right, and you should choose a median. Okay, you lose your point, you choose a mean here because the outlier. So we also have a solution here. You can look at it, right? Mean, mode, median, right? So this case, you have two modes, right? Because 39 and 41 show two times, two modes. So let's look at the skewness. Mean, median, and mode here. So here, like in 22, determine if each of the following data sets is skewed left, right, or symmetric. So for one data set, you have the mean bigger than the median, mean 36, median is 25, right? And whether it's skewed to right or left, right? So you remember if you have symmetric, right? And then mean and median should be the same. But when the mean is much bigger than the median, which is the mean get pulled up, right? So which means there's some outlier at the top side. So again, remember the example in the region bank we had in chapter 2, right? And the CEO salary, it just pull everything up, right? So for this case, this kind of thing, this kind of data, we should expect something like this, right? Pull. So something here, it pull the mean forward, right? But the median is still, because the resistance, so it's still here, right? So here the median, the med, right? And here the mean, right? So this is the right skew, right? Right skew, a skew right, skew left. So for A is the right skew. Mean is 42 and median 42. So basically in this case, we should expect it kind of symmetric, right? Symmetric. In this way, we have a long left tail, right? So it's a skew left here. Right? So most value on the right side, but some on the left. And we have the same phenomenon, right? For the age people get cancer, right? Data. We have a few kids got cancer, but most people got cancer at the end of their life, right? Because, maybe different factor from the environment. For this one, again, you get something pulled out here, right? Put in toward here, this side, right? So it's a skew right here. A right skew, okay, right skew. And you can also look at the frequency, right? So basically, if you draw more like this, right? And the height here, 5, 2, 6, right? And you connect it, you get this kind of phenomenon, right? So it is left skew, right? So 26, which is the tallest bar, right? So let's check. Right, skew right, mean greater than median. Symmetric, skew left, right, skew right, and skew left. Good. Measure the spread of the data. Section 2.7. Okay, we almost there. Use your calculator computer variance to compute the variance standardization of the dataset. Pay close attention to whether data come from sample or population. So here they say salary for all 6 employees. Okay, so which means they talk about population, right? In thousand is that. So use calculator. So basically, like what you need to care about that, like the sample here will be the this is the population, right? So you need the population variance. So in your calculator, you need to look at sigma x because it's for population, right? Population, which is the formula which is divided by n, right? For the variance. And then a sample of 5 average and high temperatures, right? In Fahrenheit for New York, right? In the last 3 decades. So here we just have a sample, right? Sample. So which means you look at the SX, right? SX instead. So you plug in your calculator, pay close attention, right? When we talk about population as sample. So here's a sample, and here population, right? So here you look at for sigma x, here you look at for SX. So let's see. So you plug in, you need to look at sigma, right? Sigma. And here they ask for you to calculate both standard deviation and variance, right? So this standard deviation, you should be able to see this number from your calculator. And this is a sigma square, which is a variance. Yeah, same thing here, right? So let us just do maybe one case, okay? So I'll show you maybe for the salary for all 6 employees, okay? Let's see. Salary for all 6 employees. So let me see, do it. We have I think I will choose a B to do it. Okay, so let us just do B together. Okay, start here. Maybe just put in L2. So 54, 48, 42, 40, and 40. Okay, so we're working on B, okay? 23B. 54, 48, 42, 40, 40. Oh, start here. Cal. And I remember change to L2 because our data is saved in L2, right? So here you can see that you have the S and the sigma. So we use the S when we talk about sample, which is 6.099 here. You keep 3. And you use the sigma here, which is 5.455 if you talk about the population. But here in this case, we're talking about sample, right? So when you use S, which is 6.099, 6.1 here, and if you keep 3, it's 0.099. But anyway, even you use 6.1, it's still okay. I don't think the difference is too much. And then S square, which will give you the sample variance, right? So here, like the notation in not here, I mean, it doesn't hurt much. So I mean, just to be safe, I just keep 3 digit, right? Keep 3 digit. So you don't have to deal with this, send them 1 or 2 or something like that. Or 4 digits, right? There's no reason to lose your energy on those things, right? And remember those. So 24, let's see 24 here. So now let us look at 24. Suppose there are an estimated sale featuring many items sold at different prices. The mean selling prices of the items is 75 and the standard deviation is 20. True or statement below is true. A business costume jewelry sale for 15. This is 2 standard deviation left of the mean. So we mean below, right? Below from the left. Sometimes people say it's left and right, which is below above. So see, like if 2 standard deviation left of the mean, which is should be 75, right? Subtract 20, right? But if you do this calculation, it's 35, right? So this one wrong. A business customer jewelry sale for 15. It's 3 standard left of the mean. So again, you just do the same thing. So you got a 15, right? So this is true here. A business costume jewelry sale for 15. This is 3 standard right of mean. So it's wrong here because this be correct already. The second one correct already. A business costume jewelry sale for 15. This is 3 standard above. Is wrong too, right? This guy correct. The basic question sell for $15, 3 is below the moon. Yeah, below and left the same, right? 200 below the mean. So wrong, right? So basically like the second option and the fifth option, right? So now let us look at 25, okay? Trevor and Jem are on cross-country running team from different schools. At the last meet, Trevor ran 5K for 14.5 minutes and Jem ran for 14.1. They're curious to know who had standard vision, who had the fastest time when compared to their own team. The table summarizes the mean and standard vision for each school. So here in terms of running, right, and timing, right? So if you run for that much amount of distance, you get less minutes, which means you do better job, right? But say here, what is the travel z-score for the 5K? So to calculate the z-score, right, we need to have a formula for that. Z travel, so I put a letter T here, which is 14.5, which is his time, subtract 15.6, and divide by 4.4, right? So if you do the calculation, you get like 0.25. You can check, okay? So which means he's about 2.25 standard deviation faster than the average, right, of his team. And for Gem, we get 14.1, subtract the mean, and divide by 5. And if you do calculation, you got 122 here. So which means Gem, in the average, he kind of faster than the average of his team, about 0.22 standard deviation. So must see relative to their own team who had the fastest who has a faster, right, 5K time. So basically, like a faster person is the one with the z-score, right, smaller, right, because the less time you run, right, which is the best that you are, right. So this is a little bit tricky, right, tricky in terms of the running time, right. Better, which means you run less time, right. So you can see the travel here about 0.25 time faster, right, 0.25 standard deviation faster than his team. But GM only 0.22, right? So this way, Trevor is better, right? Trevor. So this score is allow us to compare across data set. But for this example, it's a little bit, tricky because in term of, the better you are in term running, which is the less time you need to take, to finish the distance, right? So let's move on to the last problem about empirical rule. So in 26, SAT score are symmetric and bell-shaped. A random sample has a sample mean x bar is 1060, and sample selection is SA195. Answer the following using the empirical rule. Round is the nearest 10%. So, I mean, again, just keep 3, right? So this way you don't have to remember the rule of rounding. Approximately 1% of SAT score between 670 and 1450. So again, you need to know how far 670 compared to the mean and standard deviation, right? How many standard deviation is from the mean, right? So in other words, you need to calculate this score, right? So 670 subtract 1060 divided by 195. And if you do that, you get the -2 here. The same thing, this guy, which is subtract 1060 divided by 195. So this is this guy is 2 standard deviation above the mean, right? So below and above 2, which give you 95%, right? 95%. So the same thing, what the percentage SAT score less than A65. So you can also A65, how many standard deviation below the mean, right? So A65 here, you subtract 1060 and divide by 195, okay? So it gives you one standard deviation below the mean, right? But the question now is that asking you what percentage SAT score less than A65. So this is a bit tricky. It requires some more talk, right? It's not just directly use of the empirical rule. So what you need to do is you need to write out, right? You draw the picture, right? The figure of the empirical rule. What it tells us is 68% of the data belong to mu subtract sigma and mu plus sigma, right? So here is A65 here. And you have like here your mean, right? And you have 68 here, which means this guy you have 34%. And this you also have 34%. Okay, right? So below A65, so you should remember that because symmetric are the bell shape. So basically like this whole chunk here, you have 50, right? So which means like below A65, you have only 16%. 16, right? 16 and 34 add up to 50%. Okay. We can check it here too, right? I think the same calculation applied here. Then here we don't have a picture. Oh yeah, we have picture here, right? It's just the same, right? But here another way of explaining it. Basically in the middle you have 68%, so which means both sides you have 32, right? And which means each side you have 16. For C, approximate 1% score more than 1 for 50. So just the same strategy, right? You also calculate this score, which is 2 standard deviation above the mean, right? And which means you got the middle, you get 47.5, which means the side you got 2.5%, right? So here, this guy is 2 standard deviation above the mean, okay? 1450. We just did that in part A, right? And we know that this guy 50%, the whole, right? 50%. And the empirical rule tells us, right? We have like 95 in total, right? For 2 standard deviation. So which means this guy is 47.5, right? Which is half of 95%. So this guy, the tail here, right, will be 2.5. You can also argue, okay, because the middle, both sides will be 95, which is 2 tail will be 5, so each tail will be 2.5. So the last one, approximately 99.7% of SAT score between what two values. So this is just a 3 standard deviation below and above, right? So 3 standard deviation below the mean is just the mu. In this case, the mu is 108 and 0, right? Subtract 3 standard deviation. So it gives you the lower value, and upper value will be, so it will give you the 99.7% range. So here it calculated here already for you, which is from 457 to 1645. 457, 1645. And it also already show in the figure here, right? 4757.645. So we have just finished the review for the Unit 1 test. If there are any question you still confused or unclear, please contact me. You can either send me an email or come to my office hours.